The battleship Yamato, as she appeared in October 1944 during the Battle of Leyte Gulf. Subsequently, a large number of 25mm anti-aircraft cannons was installed, including single mountings in the forward and after sections of the deck. The Jake and Pete aircraft were carried in various combinations. With a standard displacement of 65,020 tons, the Yamato had a length of 263 meters, a beam of 38.9 meters and a draft of 11 meters. With an engine power of 153,000 horsepower, the Yamato could achieve a maximum speed of 27.5 knots, and with her load of 6,400 tons of petrol she could travel 7,200 nautical miles at a speed of 16 knots. The armament of the Yamato comprised 9 460mm cannons installed in 3 triple turrets, 6 155mm cannons installed in 2 triple turrets, 24 127mm cannons installed in 12 twin mountings, and 93 25mm cannons installed in 31 triple mountings. The reconnaissance aircraft were 3 Mitsubishi F1M2 and 3 Aichi E13A1. The armor layers of the Yamato had a thickness of 100 to 410 mm in the belts, 300 to 340 mm in the bulkheads, 200 to 230 mm in the deck, 380 to 560 mm in the barbettes, 190 to 650 mm in the main turrets, 25 mm in the secondary turrets and 500 mm in the conning tower. The armament on the Yamato was distributed like this: 3 460mm triple mountings, 2 afore and 1 abaft, 2 155mm triple mountings, 1 right before the superstructure and 1 right after the superstructure, 12 127mm twin mountings, all amidships, and 31 25mm triple mountings, all amidships except 4 abaft. The Yamato had a notable turning ability in comparison with other battleships, being able of achieving a turning diameter of 589 to 640 meters with a maximum heel of 9 degrees, when the rudder was turned at its maximum angle of 35 degrees with a speed of 26 knots. The main rudder had a surface area of 46 square meters. The auxiliary rudder was intended to increase the maneuverability of the Yamato, but its effectiveness was diminished because of its configuration, which favored resistance to possible damages at the expense of functionality. During trials, the designers discovered that the auxiliary rudder alone could not reduce the great turning momentum of the Yamato sufficiently to allow her to resume her course. The auxiliary rudder had a surface area of 16.5 square meters and was placed about 15 meters ahead of the main rudder. The four three-bladed bronze propellers had 5.7 meters in diameter and rotated at 225 revolutions per minute. With a propulsion power of 153,000 shaft horsepower, the Yamato could achieve a maximum speed of 27 knots, which was inferior to that achieved by other contemporary battleships and limited her ability to operate alongside the Japanese aircraft carrier fleet. The only one-mast crane installed on the Yamato had a 20-meter-long boom and was able of lifting loads of up to 6 tons. This crane was used to handle both aircraft and lifeboats. These openings communicated the side hangars where the larger lifeboats were stored with the exterior. To get them out of the ship, the lifeboats were moved toward the gates by means of rails. On each hangar, there was an overhead rail crane which moved beyond the corresponding gate to a protruding edge of the uppermost deck, where it lowered or raised the lifeboats to or from the water. Optical rangefinder, which had 8 meters in span and could see the horizon about 13.4 kilometers afar. A relative weakness on the battleships of the Yamato class was the design of their torpedo defense system. This one featured a vertical bulkhead located below the waterline, which had a thickness of 200 millimeters on its upper edge, where it joined with the armored belt, gradually decreasing to 75 millimeters on its lower edge. The joint between the armored belt and the torpedo defense bulkhead was a weak point, since it did not provide significant protection against transversal forces other than the resistance posed by the joining rivets. Torpedoes hitting near this joint could cause extensive flooding beyond the capability of the watertight compartment system to control it. The torpedo defense system was designed to withstand the explosive force of 400 kilograms of TNT, so it was actually on par with the counterparts used in other battleships. Unfortunately, the Yamato was hit with torpedoes fitted with Torpex warheads, whose explosive force was around 50% more powerful. The armor in the belt was made of Vickers hardened face-hardened steel plates of 410 mm in thickness with an inclination of 20 degrees. This armor was intended to withstand impacts from the 406 mm cannons that enemy battleships had and even from the 460 mm cannons that only the battleships of the Yamato class had. This unparalleled degree of protection was more theoretical than actual because the quality of the steel was questionable in comparison with that of other contemporary steel types used in other navies. A 15-meter-long swinging boom was fitted at each side of the hull. The booms could be swung through string riggings to set either a perpendicular or a parallel orientation to the hull. Rope ladders hanging from the booms were used for embarking and disembarking. Davits are folding iron arms used as cranes for lifting small lifeboats or other loads. The Yamato had 10 davits on each side of the hull. Openings in the superstructure and ventilation structure scattered throughout the weather deck allowed to replace rarefied air in the interior of the ship with fresh air. Optical rangefinder, which had 10 meters in span and could see the horizon about 16.2 kilometers afar. It was part of the Type 98 low-angle fire control system, which was intended for tracking and acquiring the range of surface targets or distant aircraft groups flying at a low speed relative to the ship. The 460 mm cannons could fire barrage salvos of cluster incendiary shells, which would detonate at preset ranges, against approaching aircraft groups. The aim of the dual-purpose 127mm battery was directed by a set of 4 optical rangefinders of 4.5 meters in span, being located 2 of them at each side of the tripod mast, which could see the horizon about 15.1 kilometers afar, and the other 2 at each side of the bridge tower, which could see the horizon about 14.3 kilometers afar. The Type 94 high-angle fire control system was designed to track and acquire the range of either surface targets, distant aircraft groups flying at a low speed relative to the ship or nearby aircraft flying at a high speed relative to the ship. The aim of the anti-aircraft 25mm battery was directed by a set of 4 control towers, being located 2 of them at each side of the funnel and the other 2 at each side of the bridge tower's frontal area. In 1944, a new set of control towers fitted with curved blinds was installed throughout the superstructure and in the aircraft deck. The Type 95 high-angle fire control system used a simple course and speed system to track and acquire the range of nearby aircraft flying at a high speed relative to the ship. The 25mm triple mountings had the advantage of being remotely controlled. The tripod mast had a small platform with 2 40cm signaling searchlights and supported the dipole array antenna of the Type 13 air search radar, which operated with a frequency of 150 MHz, 2 meters wavelength, and had an effective range of up to 100 km for aircraft groups and 50 km for single aircraft. Exhaust gases escaped through holes of 18 cm in diameter perforated in armor plating of 380 mm in thickness, being the total area of the holes less than 55% of the hull plating area. The inclined surfaces of the funnel were protected by armor of 50 mm in thickness, which would detonate bombs before they reached the perforated armor plating. The Yamato had 4 large searchlights of 150 cm in diameter, which were remotely controlled from searchlight directors. Their purpose was to illuminate targets during night fighting. These searchlights were originally 8, but their number was later reduced to 6 and finally to 4, being replaced the removed units by fire control devices. There were also 4 60 cm and 2 40 cm signaling searchlights. Searchlight directors were used to remotely direct the aim of searchlights, and their direction control was integrated into the fire control system. Each director could control several searchlights, but there were as many directors as searchlights to allow for multiple target acquisition. The horn-shaped antennas of the Type 22 surface search radar were so small that they would hardly get noticed. This radar set operated with a frequency of 3 GHz, 10 cm wavelength, and had an effective range of 20 to 35 km for ships as large as cruisers or battleships. Due to its broad radiated beam and its lack of display units and a plotter, it was only able of determining the bearing of targets, which left the determination of range to the optical rangefinders installed on the Yamato. The 13mm Type 93 heavy machine gun had a barrel length of 99 cm, 76 calibers, a muzzle velocity of 805 meters/second, an effective firing range of 1,000 meters against aircraft and an effective rate of fire of 250 rounds per minute. The Yamato had one 13mm twin mounting installed on each side of the bridge tower, along with the associated fire control device. The Type 14 optical rangefinder, which had 1.5 meters in span and could see the horizon about 17.7 kilometers afar, was used for navigation purposes. The armor in the narrow conning tower was made of Vickers hardened face-hardened steel plates with a thickness of 500 mm in the walls and 200 mm in the roof. Optical rangefinder, which had 8 meters in span and could see the horizon about 13.9 kilometers afar. The frontal face of the 460mm cannon turrets had 650mm in thickness, being so the thickest steel armor plating ever installed in a warship, while the barbettes had up to 550mm in thickness. In either case, the armor was made of Vickers-hardened, face-hardened steel plates. Each of the 460mm cannon turrets had 3 cannons and weighed a total of 2,510 tons, as much as a typical destroyer. The weight of the Yamato affected her speed negatively and, after extensive hydrodynamical tests, the characteristic 4 bulb was added to the design of the hull to allow for an increase in speed. The hull of the Yamato was in fact one of the most hydrodynamically efficient ever built. The bulb also housed the Type 0 sonar array, which could detect submarines only when the ship was navigating at low speed. With a height of 5.47 meters and a width of 2.83 meters, each of the 2 bower anchors weighed 15 tons. The hawse pipes were placed away from the ship's centerline to protect the bulbous bow from being hit by the anchors. The anchor deck was covered with checker plating. Aircraft and lifeboats were stored in underdeck hangars abaft to protect them from the fire blast produced by the 460mm cannons. An opening in the stern and a set of rails and carts allowed to move the aircraft and the lifeboats from their hangars to the exterior and vice versa. When leaving their hangar, the aircraft were placed in a well in the center of the boat deck, from where the mast crane would lift them to place them in the aircraft deck or in the catapults. From a top-down view, this well resembles an elevator, but it was not such thing. The lifeboats were stored inside hangars, which communicated with the exterior through the rails running at each side of the well. Both the aircraft and the lifeboats were lifted or landed by the mast crane. The stern deck was covered with checker plating after the hangar area and concrete on the hangar area, beneath the aircraft deck. The aircraft had 2 19.5-meter-long orientable catapults at their disposal, and a system of rails fitted with turntables and carts allowed to move them easily across the aircraft deck and to either catapult. The aircraft deck was covered with concrete and the protruding edges which supported the rail cranes were covered with checker plating. The steel deck over the hangar area was reinforced with concrete. The Yamato carried 4 Aichi E-13A long-range reconnaissance seaplanes, which could carry 250 kilograms of bombs if required. The Yamato carried 3 Mitsubishi F-1M reconnaissance seaplanes, which were specialized in spotting targets for the artillery batteries and could carry 120 kilograms of bombs if required. No less than 15 hose reels of different sizes were distributed along the weather deck to assist washing and fire extinction throughout the whole ship. The 460mm Type 94 naval cannon weighed 147.3 tons, had a barrel length of 21.13 meters, 46 calibers, and fired 1,350 kilogram shells. It had a muzzle velocity of 780 meters/second, a maximum firing range of 42 kilometers and a rate of fire of 2 rounds per minute. It was the artillery piece of largest caliber ever installed in a warship. The 155mm third-year type naval cannon weighed 12.7 tons, had a barrel length of 9.3 meters, 60 calibers, and fired 55.9 kilogram shells. It had a muzzle velocity of 925 meters/second, a maximum firing range of 27.4 kilometers and a rate of fire of 5 rounds per minute. 4 155mm triple cannon turrets were originally installed in the 2 battleships of the Yamato class, but the 2 cannon turrets located at each side of the superstructure were removed in 1944 to leave space for additional anti-aircraft artillery. The 127mm Type 89 dual-purpose cannon weighed 3.1 tons, had a barrel length of 5.08 meters, 40 calibers, and fired 23.5 kilogram shells. It had a muzzle velocity of 725 meters/second, a maximum firing range of 9.5 kilometers and a rate of fire of up to 14 rounds per minute. The 127mm twin mountings originally installed in the Yamato were 6 open mountings taken from the heavy cruiser Mogami. In 1944, the 155mm triple cannon turrets located at each side of the superstructure were removed and replaced by 6 127mm enclosed twin mountings. The Musashi received 6 25mm triple mountings instead. The 25mm Type 96 anti-aircraft cannon had a barrel length of 1.5 meters, 60 calibers, a muzzle velocity of 820 meters/second, an effective firing range of 2,000 meters and an effective rate of fire of 110 rounds per minute. In 1945, the Yamato was crowded with 25mm triple mountings, of which the largest part had a cover to protect their gunners from the fire blast produced by the 460mm cannons, which could burn the skin of anyone within a radius of 15 meters. Fire control module fitted with a Type 21 air and surface search radar and a high-precision optical rangefinder, which was part of the Type 98 low-angle fire control system. The radar operated with a frequency of 200 MHz, 1.5 meters wavelength, and had an effective range of up to 120 kilometers for aircraft groups and 70 kilometers for single aircraft. Its 2 lattice antennas were installed atop the arms of the optical rangefinder, which had 15 meters in span and could see the horizon about 21.5 kilometers afar. This was actually a quadruplex unit which comprised 3 coincidence rangefinders as well as 1 stereoscopic rangefinder to be used only under certain circumstances. Because of this, there were 4 objective lenses on the end of each arm of the optical rangefinder. All of the optical systems on board the Yamato were of the highest quality, albeit not very sophisticated. Optical rangefinder, which had 15 meters in span and could see the horizon about 11.8 kilometers afar. Optical rangefinder, which had 15 meters in span and could see the horizon about 11.8 kilometers afar. The armor in the main armored deck had 200 to 230 millimeters in thickness and was made of a non-cemented molybdenum alloy, which was superior to the Vickers homogeneous steel used in some parts of the Yamato. The main armored deck protected the area comprising the superstructure and the 3 460mm cannon turrets, in conjunction with the sideward belts and the transversal bulkheads which formed the armored citadel. The armor in the weather deck had 35 to 50 millimeters in thickness and was made of a non-cemented copper alloy. This armor plating was enough for repelling a 250-kilogram bomb dropped by a dive bomber. The weather deck was devoid of lighting openings to not compromise protection, and its largest part was lined with Japanese cypress to ease walking in wet conditions. These electrically powered chain holders had snugs on which the links of the anchor chains fitted, and they were used to either weighing or letting the anchors go. They had a clutch to connect or disconnect them from the capstan motor at will and a braking system for safely letting the anchors go. The 2 anchor chains ran around their respective chain holders and then through naval pipes into the chain lockers, where they were secured. Unlike the main capstan, the cable holders could not be rotated through hand power nor work with cables instead of chains. This electrically powered capstan, with the aid of up to 4 support rollers placed around it, could be used to move the chains of any of the 2 anchors if necessary. A set of whelps allowed it to work with cables instead of chains, and if the whelps were removed it could work as a chain holder. A pawling system and sockets for capstan bars allowed to rotate it through hand power. Screw stoppers were used for securing the anchors during navigation by turning a large bottle screw to apply tension. This way, the anchor chains did not carry the weight of their respective anchors after these had been brought into their respective hawse pipes.